Hello, students. Getting into the homework from 13.2. I do want to point out that there's certain questions in here that I love. And I absolutely love these questions like this. So if you're looking for some that says, hey, should I look at some additional ones from part A? Yeah, I would probably look at some of those. But let's jump into 13.2. Okay. And let's see here, 13.2, 2, 4 to 6, et cetera, et cetera. Okay, so let's see here. 2, choose the most appropriate metric units to measure a parallel parking space. Okay, which unit would be the best one? Square inches, kind of tiny. Square miles, pretty big, or square yards. An airport runway, again, think about the overall size. How long is that, right? So try to pick the most appropriate measure as you're doing this. So again, that's kind of the quick one there. So 2, I skipped 3 and then went 4. Now 4 and 5 are very similar. They're talking about converting units for this one right here. Yes, you do have to remember King Henry's Dear Mum drinks chocolate milk, but we're squaring everything, so everything is 2 steps to 1. So if you're moving from centimeters squared and you're moving over to millimeters, that would be 2 steps. So move the decimal 2 places. That's how we can get there. If you're moving from millimeters squared right over here, and you're moving all the way back to meters squared, you're going to go 2, 4, 6. So 1, 2, 3, 4, 5, and 6. So 0.01 would be your square meters. And I'll let you do the centimeters one as you go. If you are doing square feet to square yards, square miles to acres, and so forth, notice for acres, look back in the book, but one square mile is 640 acres. But I'm looking at, I would give you that for the exam. For right now, you'd have to look it up. But for the other ones, feet to yards, just remember if you had 99 square feet, know that you want to get rid of feet, and you know that you want to get it into yards, and 1 yard is 3 feet. I recommend the squaring part, and then just put it right into your calculator as you square it. It'd be 1 over 3 squared, and just continue on with your day. And that would get you to the answer. So this will be 9, this will be 11 square yards. Okay. Question 6, we're going to do something with this in class. If you have questions, let me know and I can make another video about it. And let's move on to, oh, actually, no, 6 is not 1. What did I say? 1, 2 through 6. Yes, 7. We'll do something with 7 in class. Sorry. So for 6, we did, you can do rectangles or you can kind of build out the shapes yourself. It doesn't matter to me. No, like it really doesn't matter which way you choose to do it. If you want to make a rectangle around this whole one, and then get rid of the other pieces. Like here's 1, here's 2, here's 3.5, there's 4, right? You can get rid of those pieces and then subtract to find what's left behind, or you can build it out. Like over here, maybe it'd be easier to just kind of break this one down and say, okay, so this is 1, that's 1, that's 1. There's a half and a half, so that's another 1.5. So 1, 2, 3, 4, 4.5. You might be able to get there quicker if you do it that way, but I'll leave it up to you as to whichever way you approve. Let's go on to question 8. Question 8, find the area in each of these. Now you'll notice at times they do throw you a little bit of what looks like a curveball, but all they're saying to do is you know the height from here to this point right there, and you also know the height over. That gives you the hint, hey, maybe I should cut this down the center so I can create 2 triangles and I can find the area of the 2 triangles. That is my hint. Decomposing into areas that you know is a huge hint for this. We'll go 8 through 13 and then over to 15, 16. A triangle and a square have one side in common. Where could the third vertex of the triangle lie if the area is exactly equal to the area of the square? Think about the formula for the triangle. What's the formula for the triangle? And they have one side in common. So what's the formula for a square? Then we start talking about similarity. So we have these beautiful ratios. Remember the square ratios. If one of them is k, the other one is k squared. So think about how you would handle the ratio here. Find the area of each part. Again, trapezoids and squares. You can use any of the formulas or break it up, decompose it into shapes if you want. Rectangular land. So this is calculating, be careful. They are giving you two different units here. My recommendation is check the directions. If it says square kilometers, then if I were you, I would take the one that is not kilometers and turn this into kilometers first, then find square kilometers. So like down here in part B where it says, what is it in square miles? I would take the yards and turn yards into miles first. That way it's just miles times miles, and I don't have to do any other computations. Okay. Let's see here. Half the area of a rectangle remains constant, but its perimeter increases. How has the shape of the rectangle changed? So a rectangle area remains constant, but the perimeter increases. Interesting. If the perimeter of a rectangle remains constant, but its area increases, how does the shape of the rectangle change? So if you want to think about perimeter, kind of, I'll give you maybe a nudge on this one. Right? So let's just say this is 5 and this is 10. So the perimeter then would be 10 plus 10 plus 5 plus 5. The perimeter would be 30, right? Now, if that stays constant, okay, so I have to stay with 30. Watch this, though. If I go down here to this being 4, right? And so the other side over here would be 4. That just used up 8, right? So if I take away 8, that leaves me with 22. So that means over here, this one should be 11 and that one should be 11. The reason why I want you to think of that is the area of this rectangle now becomes 44. But up here, the area was 50. They have the same perimeter, but the area definitely is not the same. So they're asking you a question like this to figure out, if I keep the area the same, what happens to the perimeter? If I keep the perimeter the same, what happens to the area? Okay, the rectangles are definitely changing as you go along. If you want to, you can create a rectangle in GeoGebra and find the area of the rectangle and the perimeter and have those listed there, and then kind of move it to see if I keep the perimeter the same, what's going to happen. So you could definitely use technology to help out with that. The diagonals of a rhombus are 1.2 meters and 40 centimeters long. Find the area in square meters. Definitely convert that 40 centimeters into meters first. But then, yeah, off you go. What is a rhombus? A rhombus is a kite. So use what we did for kites. What was this one? Oh, through 13. Oh, shoot, I just did 14. Sorry about that. Let's see, and then what? 15, 16, 19, and 20. So 15 and 16. Oh, this is actually a good one. This is pretty realistic. When you go to the store to buy like fertilizer or seed, fertilizer for your lawn, seed for the grass, whatever, the bag usually tells you that it'll cover a certain amount, an area of land. So what you need to do is you need to find out how big your yard is. So find the area of your yard and then use that bag just like we were converting units. Now, let me show you kind of a quick way to do that. So let's just say that I was buying, let's just say that I had like a, I don't know, like a tile floor, and I wanted to put a sealer on it. Okay, and my tile floor is 10 feet here, and up here is 20 feet. Okay, so the area of my floor would be 200 square feet. Now let's just say I have this little thing that's the sealer, and the little can of sealer will cover 50 square feet equals 1 can. So what you can do is take this and say my area here is 200 square feet, and I want to multiply by, I want to get rid of square feet, and I know the ratio is 50 square feet is 1 can. Notice I'm using kind of the same style of problem I did before. Square feet goes away, leaves me just with cans. 200 multiplied by 1 over 50 gives you 4. So I need 4 cans to do this entire surface. Treat it the same way, because all they're saying is if 1 can covers 50 square feet, that is a unit ratio then. And that can be really, really helpful as you as you go forward. Find the area of shaded regions. And they say leave your answer in terms of pi. Oh, this is a nice one. So in this case right here, they've given you the arc length of 20, which again is a part of the circumference, right? So if you find the entire circumference of the whole circle, you can find that angle. And once you find the angle, then you can find the area. So this part B is a really good question. It's a two-step problem. Over here in part A, it's not that bad. Okay. What else do we have? 15, 16, 19, and 20. Okay, let's go up here to 19 and 20. Square peg, circle hole, circle peg, square hole. This one, yeah, I would love to see this one done without any decimal numbers. Keep it as a ratio. So if you're kind of saying, what do you mean? Pick a side length, that's fine, whatever you do, and then just call it something. So for example, in this one over here, if we're doing the one on the right here, right? What I have here is I have a radius of my circle. That's R, right? Well, that radius right there, if I double it, right, becomes the length of the square's side. So the length of the side of the square is 2R. And so I could find the area of the square because I would just square that side. That's what it is. And I could even use that to find the area of the circle. So I'll do this one for you. I want you to try the first. I'll do the second. And so the percentage that is wasted, that is unoccupied, would be the area of the circle, which is pi r squared, divided by the area of the square, which is 2r quantity squared. And the reason why it doesn't matter what number I pick is when you simplify this, you get pi r squared over 4 r squared. And the reason why I'm saying it doesn't matter is the r squareds cancel out. It doesn't matter how big your radius is. It doesn't matter how big your square is. Your final result is pi over 4. That's how much is used. So how much is unoccupied would be 100% minus that, which would be 1 minus pi over 4, which is the same as 4 minus pi over 4 is the amount unoccupied. Okay. And you can now put this in as a decimal and grab your calculator if you want to. 4 minus pi divided by 4. Now you can estimate this. Pi over 4, pi is about 3.14. So it's like 3 over 4. So about 75% of it. And then what's left would be about 25% of it. That should give you a pretty good idea. But let's take a look and see if we can figure this one out. I'm going to turn my calculator sideways. And there's a pi button on here. So I'm going to do 4 minus pi, hit enter, and then divide by 4. And I get about 0.21. So 0.214. So about 21% is unoccupied in this one. So I want you to use exact values as much as you can. For question 20, again, they give you an R value. These are circular arcs. So here comes a fun fact. If you're trying to find the area of these two little pieces here, the area of these two pieces would be kind of think of putting them together. So, right, this is one half circle. This is a half circle. We'll put them together. And what do you have? You have a whole circle, right? And so then again, they're using the radius of the big circle is R. So my circle, my radius is R over 2. And then that would give me that whole green region. And that's what they're asking you to find. Find the area of the shaded parts. Okay. And all they're doing is breaking it into smaller and smaller circles. So again, when you think of smaller and smaller circles, if you push this, like cut it in half and kind of swiveled it around, you'd end up with 4 little circles. Now let's see, 19, 20, 22 to 24. Okay, 22 to 24. If the area of a square is this, what's its perimeter? Again, if the area of a square is something, you can use that to find the side of a square. Use the side of the square to find the perimeter. What happens to the area of a circle if its diameter is doubled? Use the formula. What happens to the area of a circle if its radius increased by 10%? This could tie back into what we did in chapter 6 and 7 with percent increase and percent decrease. Because when we double something, doubling something is a 100% increase. And so if you think about that, it ties right into someone who just does a 10% increase. And if the circumference is tripled, that's a 200% increase in the circumference. But again, we're talking about what happens to the area. So link back to that scale factor. If the scale factor is some number linearly, then it's going to be that value squared when you go into 2 dimensions. So if something doubles, then the area would be doubled squared. So 2 squared, or 4. All right, there we go. 22 to 24. Oh, 24. Oh, this is one of my favorite problems. So this problem is, first off, it gives you a quadrilateral, and it is dissected into perfect squares. So every shape inside of here is a perfect square. Now, why is that so cool? They tell you the red one is 64 square units. So that means it has to be 8 by 8. And the area of the blue square is 81. Okay, so 64, and this is 81. 81 must be 9 by 9. Now you use that. This is where we get to use our logic skills. 9 by 9, so this little piece right here must be 1, right? It has to be 1 because it's the difference between the 8 and the 9. But then you get to use that and say, well, wait a minute, what is this piece right here? That's got to be 9 plus 1, so that's 10. So this is a 10 by 10. Right? So this is 10 by 10. It's also worth 100. So we're trying to find the dimensions of MATH and the area being used. And that is going to be, I think, kind of cool to see as you go forward. All right. So yes, you can then find maybe this one next, and then use that to find this one. Use those two to find the big one. Use those now to find the big one over here. You can go piece by piece, but it is kind of it's a logic and a deduction puzzle. And I definitely appreciate those. All right, let's take a look. What comes next? 26, 27. So 26, the rectangle on the right was formed by decomposing, or it says it was apparently formed by decomposing these. Definitely looks similar. What is the area of the square on the left? What is the area of the square on the right? And how do you explain the discrepancy between the areas? Okay, so I want you to try this one. Try this one on your own and see if you notice any distinctions. If you think there's an issue, see if you can explain why there's an issue. If you need to kind of go draw it, you could use GeoGebra after you kind of do some thinking first and see if that helps. The store has wrapping paper on sale. One package is 3 rolls of this for $6. The other is 5 rolls of this for $8. I would recommend finding out how many square feet are in each roll, and then, use that with the cost to come up with kind of which one's going to be better. I think the last one was 34 to 35. So that's these two over here. Find the area of the shaded portion of the circles. Okay. Shaded portion of the circles. See, it kind of looks a little weird, right? So whenever I have these problems where it just looks kind of weird, I'm going to move things around and hope that I can make it happen. So I do see it's a 2 and a 4. So the ratio is 2 to 1. Okay. It doesn't give me an angle. Boy, I really wish it gave me this angle here. Like if this was 90 degrees, which I think they meant it to be, then this little region right here is the same as that little region right there. And then I have just a sector of a circle. And then outside of that, I could look at this other one over here, which is, kind of this piece over here on the side. And I could say, well, wait a minute. If I had this smaller circle, I can find that area. And then if I expand it to this bigger circle, I could find that bigger one and then just do big minus small. And that's probably the approach that I would take on this one. Break it up into pieces. Next up is find the area of the shaded quilt patterns below if one side of each square is 6 centimeters. Okay, got it. How would I do this? How would you do this? I'm just curious how students would do this one. But maybe since what I notice is some symmetry, is maybe I would just look at like one of these small squares, and then whatever I find, I just multiply by 4. And I do the same thing over here, either one of them. But then maybe I'd break this shape up, right? And then I'd have, oh yeah, so I have a white and a pink, a white and a pink, a white and a pink, a white and a pink. So I can see that the shaded region here is going to be exactly half of my square. So it's going to be exactly half of the total. That might be really helpful. And the same over here. So if I broke this down the middle, right? And I broke this down the middle, and then I kind of did something like this so I could see how many little triangle pieces are there. That might give me a fraction of the shape, and that would be easier to work with. So there's my hints, my little nudges for those. All right, that takes care of the homework out of 13 too. Have a good rest of your day. Off you go.